Hello, hello. Good evening. Good evening, you all. Thank you so much for joining. This is going to be a really good one, right? So we are smack in the middle, I guess, kind of on that down side of our heel for the month of parents, right? Making sure we had a lot of streams backed up with some resources to support parents this month. You all, some really, really good info, right? Just a quick recap. If you have not caught the live streams from the beginning of October, go back, all of them. If you are a parent or you're connected to a young person, maybe you're an auntie, a godmother, a grandmother, grandfather, any of these, uncle status, make sure that you have paid attention to because it's for the community, right? It's for the village surrounding the young person. Y'all, during week one, we talked about emotions, right? And the brain differences during week two, just different ways the brain learns and processes things, especially how it shows up in the classroom and at home. But this week right here, week three, we're connecting those ideas to content. So, how does the math itself evolve, right? And what can parents do? What can families do when those kids hit a wall? And I'm gonna say it again. Notice I said when they hit a wall, because eventually they will. They're gonna run into something that maybe isn't as quick for them to catch on to. It is not as intuitive. So, how we can support what to do when they hit a wall. So, I want you to think about it kind of like this, y'all. So, thinking about just the evolution of math, just math itself, like we're building a house, right? So maybe the roof is more like algebra, certain levels of algebra, geometry, calculus, trigonometry, all of those, right? Is the top. However, if the foundation is cracked, so some of those skills from early high school, from middle school, and yes, even from elementary, if the foundation is cracked, then the structure is going to struggle to hold its own. It's going to struggle to stand. So the key is, no matter your child's age, we can always go back and really strengthen and tighten up and reinforce those foundational beams. So that's what we're talking about this evening. We're connecting some of the dots for how it showed up in early math, and then again, the progression and evolution of it. That's what we're focusing on. So I want you to think for a bit. Even if your child is in middle school or high school right now, these early foundations, like number sense, often explain like the gaps that you see. So when we talk about number sense, because that's very much so an education space word, that just means how well they understand the relationships between numbers, right? So when we talk about one more, one less, 10 more, 10 less, right? How place values are connected by either multiplying by 10 or dividing by 10. As we go from ones, tens, hundreds, right there, multiplying by 10. When we go backwards, it's dividing by 10. So that, just the relationships between the numbers, you all, that's setting the foundation for addition, for subtraction, for multiplication, division, just the operations, right? So it starts literally with counting and them understanding, being able to pick up at any point, any number on the number line. They're getting more comfortable and they really understand that process. It even goes back to something as simple as place values. Again, a lot of the young people, that I've worked with over the years, there's a lot of disconnection when it comes to place value, where it's almost more like a song for them, like, well, what comes next? Just like there's a chorus, stanza, like a verse, and then the chorus is just what comes next, but they don't understand why that particular number comes next, or they don't understand why this is happening in a certain place value. Okay. And then they also struggle with, we call it the how quickly they can recall. Y'all know, like old school, how we used to write those multiplication facts and we had like the flashcards. Right now, that's called automaticity. Like how quickly, right, can you recognize and get to your solution? So a lot of that is coming with a lot of disconnect. It's just adding these different layers that the young people have now. So I want you to think for a moment though. When did math start feeling hard for you? Or when did you notice math started feeling hard for your young person? Y'all talk to me in the chat. When did math, you can do both. You can do yourself and then your young person, or if you prefer just your young person. When did math started feeling hard? Was it when fractions showed up? Was a lot of people like, not fractions, right? Was it when you switched from just counting and place values to now we're multiplying? Was it when people say, and a lot of young people, I don't know where these letters came from. They're talking about, right, the variables, right? Is it when the variables showed up in math class? What? I thought that was only in reading. Okay, so to say a little bit about that, when fractions show up, right? When the fractions showed up, if that was a source of some frustration, some struggle, that's when math got hard, is because really the concept of part and whole wasn't solid from early on, from previous grades, understanding part and whole. So if you say it was when we stopped counting and started doing multiplication, that's because the pattern recognition really was missing. The foundation was not where it needed to be. If you said, okay, is when these letters started showing up in math class, is because the connections between quantities and more representation, right? Abstract representation was not practiced enough. It wasn't internalized all the way. Okay. So getting into this, getting deeper. So these moments when we say math started to feel hard, we recognize that it was starting to be more difficult for our young people. These moments are usually linked to really one specific reporting category for math. We have four general areas that we call the reporting categories. And so we're going to talk about it, but I want to make sure we talk about it again from a parent standpoint so you can understand how the practice can look at home and how you'll see the progress also at home, things to look for the progress. Someone said, yes, the letters, when the letters showed up in math. Okay. Y'all, so the first area, the reporting category, we call it numbers and operations, right? So that's just understanding quantities. You're adding, subtracting, multiplying, dividing. That's place value. That's basic facts, right? All of that does connect to algebra later. Example at home, this is when we're thinking about your child estimating grocery totals, right? So whether it's having someone give them some change or they're calculating the change, which let me pause here. You all, has anyone paid with cash recently at a store? Talk to me real quickly, y'all. Has anyone paid with cash recently in any kind of store, in any kind of transaction? And especially if it was a young person at the register, y'all let me know. If it was a young person at the register, did they cut their eyes at you when you gave them cash? Were they less than excited? They were less than excited that you gave them cash because they had to do some math, right? Somebody said it was a struggle. You all, what that means is that, again, yes, the young people are having a hard time, again, with some of these basic numbers and operations. You gave them a bill, right? So that it's like $10 minus the seven something. If your total was seven something, zeros have historically always given young people some challenge. When I say zeros, subtracting with zero. So if it was like $7 and 23 cents was your total and you paid with $10, so that's like 10.00 minus 7.23, right? Young people have always had a hard time with that, but usually the more is reinforced. So much about math. We're going to talk some more about experiences. Helps, right? It helps. So they have to have the experiences. So, and it really doesn't have to be something that we like curate and make up. Not in this case, because literally math is happening all around, but sometimes we're just rolling. We're not taking that moment to say, hey, we can practice. This is a practice moment, and that will help them. And that will help them have better customer service, so they're not cutting their eyes at their customers when their customers pay with math as well, right? Someone said don't give a bill and coins. So if you give the exact change, right? So to use that $7.23, imagine you gave a $10 bill and 23 cents. Nope. All bets are off. That goes back to place value. Place value way from when they first started learning how to count, like after we counted to 100 and you're starting to get introduced to ones, tens, hundreds, that. So there's a crack that far back when young people are having an issue with the coins with the bills. That's what it is. That's what it is. It's place value. And place value, really, we jump into place value about first grade. So again, how much of an experience are we making sure our young people have, just pointing them out? Because again, so much math is happening around them. We need to make sure we're pointing it out because it's a lot that we're just doing and we're just rolling, but pointing it out, right? Okay. So if number and operations is one example, again, we're just living life. We're going to be able to do that. Then a second reporting category for math is algebraic reasoning. That sounds super official, but what it really means is just spotting patterns. Spotting patterns, being able to explain relationships. So if you see the pattern, what is the pattern, right? Is it between these two things? Is there a rule that it follows? Things like that. So that connects to what becomes equations later on. So it could be something as simple as, okay, this is our chore schedule in the house, right? Maybe it follows a certain cycle that every third day it kind of starts over. So as the young people get older, they see the first, second, third, fourth day. Hey, can you predict what the fifth, sixth, and seventh day will be on the chore schedule? Predicting patterns, right? Spotting their relationship. Maybe they're helping in the kitchen, and so they're talking about doubling a recipe, right? We have more people coming over, some family, right? Your auntie and your cousins are coming over, so we're going to make a little more. We need to double this recipe. So then what? Y'all, that wasn't anything special. That was you living regular life, but you made sure to point it out, have talk about it while y'all are working on it, right? Nothing special. Well, we have to point these spaces and experiences out. Another reporting category is geometry and measurement. That's number 3. There's only 4. Yes, in the whole wide world of math, right? So number 3, geometry and measurement. So that has to do with obviously shapes, but visualizing shapes, their size, the space. So that connects to design, problem solving, right? All around spatial themes. So this could be something as, okay, maybe y'all decided, hey, let's rearrange the furniture, right? So you see how different angles and different shapes fit into each other, or not so much, not so well. It can be comparing room sizes, right? The fourth reporting category, data analysis and probability. That's super official, but think tables and graphs, y'all, right? Think tables and graphs. So it's just how we organize information and what we understand about it. That's what that is. But this also connects very officially to critical thinking and decision making, right? If you're tracking stats for the game, right? It's Sunday, football's on. You're tracking stats for the game. Maybe you're looking at the weather patterns and you're starting to make some predictions. You're noticing a certain trend, or something as simple as you're tracking daily screen time, right? The young people can do that, right? It might be whether it's like an app that they have. What if you took it off the screen and they have a little table they set up to keep track of it? So they start to understand, oh, I did a lot on Wednesday. I might want to slow down or else I'm going to run out of minutes before I get to Saturday, right? So again, it has to do with not just them receiving the information, but are they able to organize it? And what do they understand about the information that they're seeing? Excuse me, y'all. Look, speaking of weather, the weather is changing here, and I think I have a little bit of a tickle in my throat. Excuse me. So, when we're talking about, again, math, we went through those 4 reporting categories, right? Super official is, those are the titles for it, but I hope you all understood what they consist of, right? How we do those every day. I want you to think about these instead of, ooh, reporting categories. There's like 4 math languages, those 4 areas of math. So that's what you might hear in education spaces like at school, maybe on the news, school board meetings, things like that. You hear people talk about math readiness, right? Or even if you're reading like the accountability rating, right? Your school's campus report card, when it talks about readiness, y'all, it's about fluency. So if we said that math is its own language, there's 4 parts, 4 areas of the math language, then fluency is really about being able to choose the right language at the right time, right? Like, oh, this is something that has to do with operations and numbers. So these are the kind of words that are on my mind. Oh, now we're talking about geometry things. So these are the kind of words and patterns I'm starting to look for, right? So it's about the right language, the right area of math at the right time. Yeah, that's what fluency is. That's what math readiness is. It's not, let me tell you what it's not. So math readiness is not about a certain grade level, not a certain skill within that grade level. It's a thinking skill. And so a thinking skill that applies to everybody, K 12 and beyond, right? It really grows with curiosity, with language, with your experience. I want you to remember those 3 things, those CLE. So we make sure we're giving them in building their curiosity, we're giving them the language, the vocabulary, right? Connected to that. And then an experience, something for them to anchor onto. For example, I'm going to give you some examples. Even if they're 5, y'all, they're sorting socks by color. That's classification. So that's getting them ready for data, like we talked about the tables and graphs, right? A second grader who can explain that 4 plus 3 is 7 because 3 more makes 10 is already showing number sense, right? That they know, okay, if I had 3 more, I would be at 10, but I was 3 less than 10, so I know I'm at 7. They can explain it a few different ways. That's true number sense, not just memorizing things. A 6th grader who's using some of the language, racial language, they're talking about for every 2 of these, there's 3 of those, whatever these and those are, right? They're applying proportional reasoning, which is rooted in very early comparison work, where we start to compare, right? What's greater than, less than, are they equal? That leads up to the ratios and the proportions that they do more in middle grades. A 9th grader solving an equation, right, is using balance and equality concepts that they first learned when they actually had the physical manipulatives, when they had the counters, maybe they had blocks, they were building equations at a very early age. Think about when you first start learning and setting up your addition sentences and you had 2 plus 5 equals, didn't they show you 2 items? Then you were shown 5 items. Then they were like, okay, what's the total? Right? That's how it starts. And that is really how we continue to learn. Going from touching things, right, the concrete, to the representation. Let's see pictures of it, or let's draw pictures of it. So now there's no pictures. I'm not touching anything. When I see 2 plus 5, I can figure out I have enough experience, like we talked about earlier, these experiences to know that it's 7. I know what to do to figure out that it's 7. So when kids are missing the why behind things early, yeah, they're going to hit frustration. They're going to hit frustration later, and later is sometimes sooner than later, depending on what the skill is. But the good news is we can always go back and rebuild these connections really at any given time. So with some of my direct work with kids, unless the parent has like a hardcore request or something like review this study guide, here's the test tomorrow, or unless it's a very short session, y'all, we rewind the tape. So we go back and play and create. We build numbers using the base 10 blocks. We build fractions. We build equations, tables, graphs. Again, building the curiosity, giving them the language, right? There's certain vocabulary that goes with certain areas of math, and they have an experience to anchor it to. That's the goal. That's the goal. So I want you to think about this. Y'all, how many ways can you think of to get to the number 12? How many ways can we get to 12? I'm going to give y'all some time in the chat. Drop it in the chat. Drop it in the chat. How many ways can we get to 12? All right, let's see. Because maybe you're like, okay, 6 plus 6 will get the job done. Someone, let's be clear. Let's be explicit though. Say the ways. Let's be specific. So this is a math talk. This is how we have some math conversation. Y'all are telling me many ways. Surprise me, impress me. What are the ways? I'm listening. Just give me a few. Just give me a few. So 6 times 2. So then 10 plus 2. And then 4 times 3. So some addition, some subtraction. You all, that is simple because y'all like Anika, really? Really? Y'all, something this simple is definitely how you could introduce and kind of figure out how deep and how comfortable your young person is with certain math concepts. Because as the adults, a lot of us went to the multiplication, right? But sometimes when they're especially middle grades or getting more into integers, I love it. That's when they start putting in the positive and negative numbers. They're really thinking of all the ways they can get to 12, something as simple as that. Then imagine saying, okay, so we have all these different math ways we can get to 12. Are there some ways that we see 12 a lot in real life? Are there some ways that we see 12 a lot in real life? Right? Where do we see 12 a lot in real life? In this segue, right? So we started out talking about 12 and just math ways, math operations to use to get there. Now we're connecting it to every day, right? What are some everyday situations where we might see 12 in real life, right? On the clock, a dozen eggs, a dozen donuts, months in a year, right? So y'all see how, again, a lot of this comfort or familiarity slash, oh, math really is everywhere. It doesn't have to be a heavy lift. It's a lot of it is just conversation, building their curiosity, right? I sparked y'all. Y'all were like, I got too many ways, Anika, right? Y'all were flexing on me. I have a lot of ways, I know. So building that curiosity, because that's like a challenge. And the kids like the hashtag challenge, right? How many ways can you come up with? They're like, how many ways? I built the curiosity. We had some language, right? Some people came back and said addition, subtraction. We talked about multiplication as well. Okay. Then we also connected it to a specific experience. So we talked about the real world situations. Y'all, that's it. I never wanted to be hard, right? Where the goal is not for parents to feel like, oh my gosh, I have to be a teacher at home. That's not it. But what we do want and we do need you to make sure that when there are those teachable moments, we point them out and we lean into it. That's what we need. And that you're encouraging as you do it, right? You're encouraging slash, you don't have to have all the answers. We just had a post about that. You don't have to know all the answers, but we want to make sure that your child knows that you're there with them while y'all are figuring that out, right? So, y'all, for young kids, they're practicing, we call it composing and decomposing numbers. You may remember this. You might remember you're feeling like you have to be a math teacher at home. Is that what you're saying, Mel? Yeah, a dozen eggs, definitely to get to 12. You all, when you're practicing with your decomposing numbers, that is literally when we want to make sure kids understand, we call it adding up to 10 and being able to subtract within 10. Now, that might seem really random, but let me make sure y'all understand the method to the madness. Remember earlier, we said after counting, Young people understand place value, right? So the ones, tens, hundreds. And we said that each place value, when it increases to the next, it goes by 10. So if we can make sure young people understand that adding and subtracting with intent, then when they get to place value, they're going to understand that pattern, whether it's ones, they're going to understand that pattern, whether it's the tens place, hundreds place, thousands, and so on, because they have some familiarity with it. Also, that adding up, what's one more, what's one less, 10 more, 10 less. Yeah, that's addition and subtraction basics, right? When we know we're subtracting, we start in the ones place, that kind of a thing. Is we're making sure that we're doing the little experiences that we can to help them. So again, no, because it's, because being an educator, educators are professional. They were trained for this, especially once you get to certain grade levels, especially, right? They become specialists that much more so. So we want to make sure that, yes, parents have some tools, some things that they can do at home, but no, not where it's like you feel like you have to have a whole whiteboard and all the manipulatives and all these things trying to teach these lessons and whatnot from scratch. Okay. Want to make sure you have some go to moves. And I'm going to take a moment to say this. If you have missed some of the parent resources that we've dropped earlier in the month, make sure that you click on the link in our bio, right? Our stand store. There's a section that says parent resources. There's at least 3 free resources up there right now for this month. Make sure you sign up and get them, okay? I'll drop the link in a bit. Middle schoolers. We would expect middle schoolers to talk a lot more about kind of in the multiplication and division space when they were doing a task, something like that. But then we talk about giving language, we would want to hear them say factors in multiples, products, right, and quotients. So that's what we're leaning that much more heavily into the language by the time they hit middle school. For older students, when we're talking about the equations, maybe they're writing full equations and understanding more about the ratios and proportions, again, certain language, and then definitely specific experiences that they'll be able to connect it to. So I'm gonna give y'all some more. I'm gonna give y'all some more because again, it's just talking points, talking points to make sure the young people aren't putting math in a box in math class. Like, I'm out of math class. Woo! Glad that's over. That they understand how really you all and them included are using it quite a lot at home. So let's say that you're at the store, you're buying 3 items, and it's $8.95 each, right? What if you ask your child, if they're a certain age, to estimate the total without a calculator? So for them, they would have to round, they would multiply or add, right? So again, we talk about cooking. We talked about cooking with doubles and halves. Yeah, a lot of young people have issues with fractions, but they help out a lot in the kitchen. In the kitchen, we have the measuring cups even, right? Literally, I had a young lady go get the measuring cups because we were just trying to give her a lot of layers, a lot of experiences when it came to fractions. We used some blocks, we used fraction circles. We talked about if it was pizza, if it was a cake, right? So I said, you know what? Because she mentioned that they have some measuring cups. I said, go get them. And we looked at them and she talked about what she noticed. Said, oh, yeah, the fourth. Oh, I remember I needed 2 of these to be the same thing as a half. Like, she knew that from cooking, but it wasn't transferring to math class until we literally talked about it and brought it to math, right? So just that could be something. Again, we're cooking, right? Give them a challenge. Well, how many forks will we need to fill up this half cup? They're right there to do it. It might take a few extra seconds. Let them do it. Let them discover. Let them play and discover. Again, a lot of when I'm starting to work with the students I work with directly, we play, we build stuff. Right? They're used to sitting there like this, maybe. When people are talking about math, right? They might be talking about math around them, not necessarily including them, or they're doing math, but they jumped in too early instead of letting them touch and build the math first. So as much as they can have experience where they're touching and doing and talking about the math, y'all, these little things help. Building with Legos, just let them play. Grocery budgeting. Soon, a lot of kids are going to be having the book fair come to the campus, right? Let them write down a little wish list. What books would you like? Write them down. It's just, we don't know. We're not saying that you're going to get it for sure, but perhaps, right? So once you have your wish list, okay, I need you to get an estimate together for me. I need you to round these. About how much would this cost if you had all of this? While they're doing that, you decide, okay, so I'm giving you a budget. I'm sorry, you're not going to be able to get all these, right? But with your budget, now you can choose which books could you get with this. And this is real life stuff. This is real life stuff, but this is regular things. And these are things that they can handle. And we want them to have these experiences because they're going to come ask you for money anyway. Ha ha. Right? So you might as well have some conversation around it. All right. Well, how much do you need? How do you know? What if I gave you this much? Right? How much change back? You see, just make it a part of the conversation. Don't make it be extra or feel like extra. Just a part of the conversation. You have young people that are in sports. Do we have conversation around their own sports data? Right? Do you have a child that plays soccer, plays basketball, plays anything, right? Think about it, instead of just like, oh my gosh, when I go to class, we make these tables and these bar graphs. What if there was some conversation around their own data and they made a little table for themselves, made a little bar graph for themselves? Because it's something that's theirs, they're used to it, they understand where the data came from, and now they're creating their own. And y'all, that's something you can watch them do. Because I know sometimes we might be like, oh, I don't want to have to hover over them and show them an example. Sometimes young people struggle because they don't have an example for what we're asking, where we want them to be, right? So show them an example to help them get there. I want you to take your data, right, from your game today, and I want you to make a bar graph, right? Show me. Show me how many free throws you got. How many 2-pointers? Did you make any threes? Show me on this graph. Put in the table first. If you have a young person that is very inclined to music, right? Maybe they're a dancer, they're in band. They understand these pattern recognitions in the beats. That's its own conversation, even for not just pattern recognition, but it can get very specific for fractions, right? There's whole notes, like one whole. There's half notes, quarter notes, eighth notes, sixteenths. Especially if they've seen it written, the notes are smaller. So that's its own visual cue as well, in terms of when we're comparing what fraction is larger, what fraction is smaller, why, how this works. All of this is great starting points and good conversation around that. Again, not that you have to teach a full lesson on it, but just introducing it so that you're helping to build that curiosity. So we also talked about travel routes sometimes. All right, so we know it's going to take us 8 hours to go from Dallas to New Orleans, right? What if mom is driving 70 miles per hour most of the time? How long will it about how long, right? Will it take us to get there? And so understanding what patterns they understand, what operations they think they need to know to figure that out. So it's a lot of things that, again, we do as adults. Yeah, we have to let them in. We have to say some of this out loud. And that will help. That'll help them make the connections for, again, how much math is in our everyday / where they can use and where they do use math. It'll help them make some connections. And really, the hardest part that people have with math sometimes is the connections, right? A lot of times people grew up and say, I never use that. I don't know when I use this, right? So it's just the perspective thing. A lot of people, the favorite thing, I have never used Pythagorean theorem. It's like maybe you haven't articulated it that way. Maybe you haven't had to do a squared plus b squared equals c squared exactly, but you've lived out the concept a number of times, right? If you are going on a walk and you could walk 2 miles up and 3 miles over to make the block. I'll say two blocks up, 3 miles, 3 blocks over, or it's a park that runs straight on a diagonal, right? And you want the fastest way, you better take that diagonal. Yeah, that's Pythagorean theorem in real life. If you took the diagonal, you took the shortcut, the fastest way, you literally walked and lived the Pythagorean theorem. How about that? But again, there's just certain things that, again, there's a disconnect that we need to make sure we're saying things a certain way. That's probably the biggest ask from tonight. Making sure that we are using certain language, right? We're building their curiosity, right? Using the language, because again, a lot of the language is going to be, even if we don't know the vocabulary exactly, we're giving them some of the perspective. We may even wonder out loud, this has to be connected to a math something. I wonder if we can figure out the math something. What is this connected to? That curiosity is sparked. Let's figure it out. Or let them go do some research and figure it out, right? Sometimes we are honestly holding the kids back for what we think they can do in research. Especially, y'all know they are tablet and device professionals. Let them go do some research and figure it out. What did you find out? What is that connected to? Right? And so you gave them some space to explore it. And again, as the adult, you didn't have to be a math teacher, quote unquote, but you sparked the curiosity and gave them space to explore and to experience. Okay? Y'all, you know what? I'm going to stop here tonight. There's so much more. I'm about halfway through what I wanted to tell y'all tonight, but y'all know I don't like to hold y'all too long. But the major takeaways, again, one, so I want your challenge, right? I'm going to challenge y'all. Your challenge is to help your young people see how much math already lives in your day. To see how much math already lives in your day, everything from your scheduling, right? To your time travel, your commute, to your measuring as you cook food, so many, your money as you're calculating maybe your budget, as you're determining change you should receive back, right? And getting that side eye from the young people because you're paying with cash. But that's your challenge, to see how much math, connect that for your young people, how much math is already living in your day right now. So readiness, again, we want our young people to be math ready. It's not just about noticing, oh, okay, yeah, this is probably some math, but being able to name it, being able to understand the experience and use some of the language, the vocabulary that goes with it, right? Yeah, so I'm gonna stop y'all because I was like, I have a lot more that I could say, but I do want to remind you all of this. We do have our Back in the Groove parent pack, right? Our Back in the Groove parent pack that we have on the same link in the bio link that has some excellent prompts and math talks for you to have with your young people. On the Stand store, we also have some details for how much support, navigating how much support to give during homework, not just how much to give, but also asking your young person how much do they want to receive during homework time. So a lot of good resources that are free and some that are even more rich that are paid, especially the Back in the Groove parent pack. I keep talking about that one because that one was designed with more so the beginning of school in mind and just kind of getting in your flow, getting in your groove. And even when you're having some of those kind of tough, uncomfortable conversations about grades, just some starting points for how to discuss some of those things. Okay. Yeah, but y'all know how to find me if you have any questions between now and next week. Okay. So next week will probably be, it might be a little bit longer because that'll be the last one for October for our month of the parent. And I definitely want to make sure I leave y'all with a lot of good stuff. So if you have any questions in the meantime, send me a DM. Some of y'all may have my phone number. Send me a text, right? Y'all know how to reach me. But thank you again so much for listening in. Check out all the resources. I can't stress that enough, y'all. I literally made them so parents, families can use them. Use them. We've been getting a lot of good reviews on them. Yeah, use them. They're good. Thank you. I'll see you next time. Bye-bye.